Hello, Mario! In this video I'm going to do a bit of an introduction, just a basic introduction to optical levelling. I say optical levelling because it involves levels that you look through and take readings. These levels are referred to variously as a number of names: a dumpy level, spirit level, and what have you. And the message that we use, or the description that we use, is quite often can be referred to as differential levelling, but I've just called it the optical level because it clearly defines the type of level I'm talking about, which is one that you look through and take the reading. And now these have been updated, of course, and we now have digital levels as well, but that will be the subject of another video. An optical level, essentially its basic function is that it defines a horizontal plane, and then by measuring the differences, or by measuring the vertical distance above or below that horizontal plane defined by the level, the difference in height between various objects can be worked out from the readings that we take. And I've shown the readings here as R. You'll notice that this one here, this is one where the staff is upside down, so the reading is taken from the bottom of the staff would be here and downwards. These are usually shown with a negative sign when we're writing them. So here's a little distance above the floor level there, there, distance above the curb to the horizontal plane, there, centre line there, curb there, manhole there, and then over here we have a benchmark. Now a benchmark is usually a mark that has a known height in terms of a known datum, and so that by measuring to that we can then work out the heights of these features in terms of the known datum. Now a datum that we use in this area and around the Waikato is the Motoriki datum. The zero of the datum is mean sea level, and that was measured at the tide gauge at Motoriki Island, which is near Mount Maunganui, very, very close there. The tide gauge, the tide varies through a cycle of around about 19 years, so a tide gauge is set up there and measures that cycle and determines mean sea level. Then, having determined what mean sea level is in terms of a couple of benchmarks on the area, we're able to put heights on those benchmarks, and so that we know that sea level, or mean sea level, is just slightly below whatever those values are below that benchmark. And then from those benchmarks, further benchmarks are established inland in various ways and circuits. So when we have a benchmark and it has a known height on it in terms of Motoriki datum, that's the datum, the zero is at Motoriki, sea level at that area. So when using a height on a plan or for referring to someone, it's important that we know what datum we're in terms of, because obviously if you think you're in terms of one datum and you're in fact in another, that's going to introduce, or can introduce, various errors. So it's usual to refer to the datum, and over in this way that would be Motoriki datum, and the origin of heights. So for example, you might see this on a plan: heights in terms of Motoriki datum, origin of heights, BM, benchmark, AB4G, RL, which is reduced level, 24.563. So that would indicate that that particular benchmark, or the top of the tip of that benchmark, is 24.563 meters above mean sea level at Motoriki. And it's important that you have both, that you indicate what datum you're using and what your origin of heights is. In some cases a height datum is assumed, that you do not have sufficient information, and so you could put a statement like this: heights in terms of an assumed datum. Origin of heights, still need the origin of heights because the datum is assumed. Origin of heights is iron tube 12 DP 409786 RL 100.00, and we've used 100.00 because that will give us a good range so that we don't start getting any negative heights, depending where we are, of course, in the height range of our job. So these should be considered very carefully, just to make your the whole job just that much easier for you in terms of how you deal with the numbers. So let's just have a look now at the leveling staff, and here we have a picture of the typical metric E leveling staff. These extend out to 5 meters, usually in 5 sections, or in some cases 3, and these leaves or sections extend out. So it's very important that when you're extending the staff out that you make sure it clicks in place so that it is in fact 5 meters tall. Remembering, of course, that a staff fully extended at 5 meters is quite vulnerable to coming into contact with overhead wires and things like that, and the staffs, usually made out of aluminium, conduct electricity quite well. So be very careful when you're dealing with overhead wires and aluminium staves. The general rule is that if you're going to come anywhere closer than 4 meters of a wire, you need to take extra care and possibly have people in place as spotters and experts in place that know how to deal with those wires. One of the ways of dealing with the overhead hazard is to actually remove some of the sections from the staff so that it's physically not possible to extend the staff the full 5 meters. Essentially, the staff is a giant ruler, and it's graduated so that when you look through your level, it's quite easy to read. There are a number of different formats for the way the readings go, but generally this metric E one I find is quite the easiest one to read and the easiest to understand. Remembering that any errors that you make in readings will transfer right through the whole job, so it's important that you get those particularly right. Now, so just some tips on reading the staff. The first thing is that you point to the staff, focus it up quite clearly so that you've got a nice clear view, and read the staff. Always 3 decimal places. You estimate the millimeters. So for instance, these here would be some typical measurements, 0.263. Note, you always put the 0 and then a decimal point so that you know that it's between 0 and 1. 1.540. The third 0 indicates that it's exactly on the 40. It's not 541 or not 539. So again, always the 3 decimal places, always at least one number in front of them, although with a 5 meter staff it will always be 1. And then another example there, 3.071. Nothing spectacular there, but just to show always the 3 decimal places. So read the staff, write down the reading, write that in your field book in the appropriate place, and we'll be showing you how and where and what to write. Then go back to the staff and read it again. Check it is what you wrote down. So you go back, check it's what you wrote down. Yes, that's what I wrote down. And then you can move the staff man on, because the staff man moves through, so quite often you can't go back to the same point in some cases when you're traversing forward in the leveling situation. Just in terms of the little picture that we've got here of the metric E staff, the reading there is 1.559. So you can see 1.5, the top of the E is 5, so 1.55, and then it's approximately 1 millimeter below the start of the next centimeter, so 1.559. The thickness of the graduations, 10 mils between them. Okay, so 1.559, that's what I've written down. Now, sometimes, as you saw in the previous slide, where the staff is held upside down, this is obviously, you need to show those readings as a little bit different, and they're shown as negative. Now, how you do that's probably up to you. Some show it as negative 0.542 if that was a reading, but however, in cases like that, sometimes it's very easy to overlook the negative. So there are some schools of thought that suggest that the best way is to put a bar across the top, as I've done there. So that would be negative 0.542. No doubt that that is negative. But just to reiterate, it is very important that you check your readings and that you get them right to the millimetre, because any errors carry forward in the process of what you're doing. So there you are. That's a brief introduction to optical levelling, and let's hope that can give you a good start and enjoy your time looking through the levelling and finding out more about levelling and how you can use that to take measurements that are relevant to the construction and engineering that you will be doing in the future.